Hi guys, welcome to another episode of MrLopezClasses.com. This is the episode number 2 of the chapter 3. This chapter is dedicated to the materials. And in this specific episode, we are going to talk about the metals and non-metals, the difference between metals and non-metals, and we are going to talk about the transition metals, those metals located here in this section. They are called transition elements or transition metals. Yes, we are going to start to define the metals, the non-metals, and after that we are going to continue with the classification of the materials in two big brains, in organic materials and inorganic materials. Okay, my friends, in the last episode we identified the different type of groups. We have A groups, A main groups, and we have the orbits. 1 orbit, 2 orbits, 3, 4. But the classification is according with the amount of electrons in the last orbit. This is the most important part. In the periodic table, we found that a division is a division here, here, exactly like this, here, here, and finish over there. Is boron, silica, arsenic, tellurium, astanium. Here is like a ladder over there. That division is very important. Why that division is critical when you study the periodic table? It's because below that division, those elements are considered metals. And over the division, those elements are considered non-metals. Ah, nice. The metals, all the elements located below the divisions are considered metals. Except for one. This one, hydrogen. Because hydrogen is located over there, basically because hydrogen only have 1 electron in the last orbit. However, hydrogen is not a metal. Hydrogen is a gas, but it's located over there. This is the only metal, the only element that is located in the group of the metals, but that is not a metal. It's only for configuration of his structure. It's located over there, all right? But the rest of the elements are metals. Yes, all of them are metals. Calcium is a metal, yes. Magnesium, yes. Sodium is a metal, yes, it's a metal. They have different names. Those metals located here are called alkali metals because they are coming from alkali earths. The majority of those metals react in contact with water. Yeah, but those metals here located over there are transition metals, very important metals for our program, for our career, transition metals. And the metal located here, aluminum, germanium, all of those are metals. If you see the division is here. There are 3 elements located in the limit, in the edge of the division. Those elements are carbon, silica, and germanium. Carbon, silica, and germanium. Those 3 elements, they are in the limit in between metals and non-metals. For that reason, those 3 elements are considered semiconductors. Semiconductor, what is the meaning of that? Those elements, silica, germanium, and carbon, work like a metals or non-metals depending of what? Depending of the temperature. Yes, depending of external factors like temperatures. Those 3 elements, carbon, silica, and germanium, work like a metals or non-metals depending of the temperature. For that reason, in the future, we need to take a special consideration in both fabricated the hull in carbon fiber because during the summer, in the Caribbean, for example, with the high temperature, those hulls become metallics. And we need special considerations in the bonding system, the ground of those boats. Because of those boats, in the summer, the hull is a perfect metallic hull. And you need to be careful when you install equipment, especially electronic equipment. You need to be careful when you attach those elements to the structure of the boat, because the structure becomes metallic in some situations, especially carbon. Remember, carbon, silica, and germanium, those three elements are considered semiconductors. Important factor. Where are located those three elements? In carbon, silica, and germanium. Those three elements are located in the group number 4. Those elements produce excellent structure, because the people ask about why the carbon fiber and the fiberglass, the structure is strong. Let me demonstrate why. Suppose that we have a carbon fiber. We have the structure of the mat of carbon fiber. That heavy structure is basically carbon, atoms of carbon together. Let me check what happened in that structure. I have carbons, I have carbons, I have carbons, pure carbons. And let me verify how many electrons have a carbon in the last orbit. 4 electrons, no? According with the periodic table, it's located in the group number 4, is 4 electrons. Each atom have 4 electrons in the last orbit. What happens if I put more carbons and more carbons and more carbons and more carbons? Yes, all of them, they have 4 electrons in the last orbit, and they can create covalent reactions in between one and the other one. They share electrons. They share electrons. At the end of the day, each atom complete 8 electrons in the last orbit. Complete 8 electrons in the last orbit. 1, 2, 3, 4, 5, 6, 7, 8. And the structure is a perfect structure. It's strong because it's not possible introduce additional elements, because the structure is perfect. The bond of the system is perfect. Each atom complete 8 electrons in the last orbit because share other 4 electrons with other 4 carbons around the structure. This is a perfect structure. It's a wonderful structure. For that reason, when you cover that mat with a resin, you have a strong structure. The carbon fiber is wonderful, is perfect. We are going to study later the carbon fiber, and we are going to study why the carbon fiber reach tensile strengths superior than the steels, and torsion strengths superior than steels. For that reason, the majority of the bicycles today are fabricated in carbon fiber. The chassis of race cars are fabricated in carbon fiber. It's because that structure is perfect. It's perfect because you don't have the possibility to introduce any other element in between, because the structure is completely closed, is hermetic. Exactly the same situation is with silica. With silica, it's basically the same. You have silica and carbon are in the group number 4, and once again, all of them, they have 4 electrons in the last orbit, and they produce covalent reactions with the other ones. And complete 8 electrons in the last orbit. This one is used for fiber because the silica mat is that one, is used in the fiberglass. This is used in fiberglass. Because remember, glass is silica, glass is sand, glass is silica. This is for fiberglass, and this one is for carbon fiber. This is for carbon fiber. Oh, the fiber in the carbon fiber structure is pure carbon. The matte is that. In fiberglass, the fiber is this matte, and is also a perfect structure. The only difference between both of them, between carbon fiber and fiberglass, is the resin. In carbon fiber is recommended use epoxy resin, and in fiberglass normally the people use polyester resin. Polyester resin with fiberglass and epoxy resin with carbon fiber. That's the difference in between both structures. But both of them use those elements located in the group number 4, carbon, silica, and germanium. In electronics, we are going to learn later germanium and silica are materials commonly used in the fabrication of circuit boards. Those elements are perfect because the structure is a perfect structure, not react with the environment. But the inconvenience with those structures, with those circuit boards, is the temperature. Remember that when those elements, silica and germanium, become hot, become metals, and that's not good for the circuit boards. For that reason, the majority of the circuit boards, they have a fan located in front of the circuit board in order to to protect the circuit board and avoid that the temperature increase dramatically. This is the enemy of those structures. Okay, transition metals, carbon, silica, and germanium. Very important. Okay, now we are going to analyze the elements located in this period. They are called transition metals, transition elements. The majority of those elements located in this group, in between this point and this point, in between scandium and copper, they work in the last orbit with 3 electrons. And only this small group, zinc, cadmium, and mercury, they work in the last orbit with 2 electrons. This is very, 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 very important. Because right now we are going to understand why elements like zinc are used to protect other metals against corrosion. And this is the explanation. Right now I am going to explain why the majority of the elements located in the transition group, they work with 3 electrons in the last orbit, with 1 or 3. But the elements located in this small group, they work with 2 electrons in the last orbit. What type of metals are located in that group of transition metals? The majority of the metals that we use every day in our business. Iron, copper, nickel, chromium, molybdenum, titanium, gold, silver, zinc. All of the metals the majority of the metals are located in this transition metal, in this transition group. Let me explain something about why those metals are the preferred metals for the different industries, automotive, aviation, marine, industrial. Those are the preferred metals. Because the metals in general, they are good conductors of electricity and good conductors of temperature. Yeah, we are going to study later in our next course of electricity the flow of electricity. But only for a short introduction to those courses, electricity is basically the flow of electrons. Electricity is basically the flow of electrons. And I want to explain how the electricity moves through the cables, through the conductors, easily in this simple example. Suppose that you are driving your motorcycle in the morning, 6 a.m., 7 a.m. in the expressway. It's easy at 6 a.m. in the first of all, in the most important expressway of your country. It's easy move in your bicycle at 7 a.m.? Probably no, because the traffic is heavy. And the concentration, the amount of cars in the expressway is full. It's difficult. It's difficult move it. That expressway is practically full of cars. When the expressway is completely blocked, it's because the expressway have 8 electrons in the last orbit. It's full. It's not possible move it. For that reason, those elements located in that group, they are considered noble gases, noble elements, because they don't react. They are full. They are relaxed. The element located in the group number A, they have the last orbit full. The maximum is A, you remember? A is full. The element located in the group number 7, they are practically full. They only need one additional electron. You think that those elements are good conductors of electricity? You can move your motorcycle easy with 95% of the cars in the expressway? No. For that reason, the elements located here are considered non-conductors, non-metals. Non-metals. You remember the division? Non-metals. The non-metals in the groups 6, 7, 8 are bad conductors, non-conductors. What happens if you try to move your motorcycle in the same expressway at 11 a.m.? Probably the traffic is better. There are cars, but it's easy move it. Yeah? If in the last orbit you have probably 3 electrons in the last orbit, it's easy with your motorcycle move it because only are 3 and you have a space to move your motorcycle. Because the expressway is not saturated, only have 3 electrons. For that reason, the metals located here are the preferred metals for everything, because they are excellent conductors of electricity and temperature. Okay, it's clear? We are going to study later in the course of electricity with more details that explanation. Okay, my friend, but it's clear that those elements located in this transition group are excellent metals, excellent conductors of temperature and excellent conductors of electricity. Let me explain what happened with some specific elements located over there in those groups. Suppose that we have this situation. Remember that I explained that oxygen tried to attack the rest of the metals in the periodic table. Okay? We are going to study in particular what happened when oxygen tried to attack, for example, iron. Where is located iron? Iron is located here. Iron is located here, with the iron work with 3 electrons in the last orbit. And we are going to create the oxide of iron. When the oxygen attack the metals, produce oxides. This is other important consideration, my friend. I explained that the metals, all of them are excellent conductor of electricity. Yeah. However, when the metals are attacked for the oxygen, for example, you remember when you have a piece of aluminum and you put the aluminum outside in your home for 3 days, expose it to the rain and the sun. In 3 days you touch the aluminum and you found it like a white powder. That white powder is oxide of aluminum. That white powder, what happens if you let the piece of aluminum not 2 days, not 3 days, 1 year outside of your home. Probably you found a lot of white powder covering the metal. Yeah? That white powder is a perfect isolator. That white powder is a perfect isolator. For that reason, that powder, the oxide of different metals, oxide of iron, oxide of copper, oxide of zinc, those powders are used to fabricate ceramics. Yes, my friends, ceramics. The ceramics is oxide of metal with glue. The ceramics are perfect isolators. And we are going to study in our course of corrosion in details the ceramics and the behavior of the ceramics. But the metal by itself is perfect conductor. When the metal is oxidized, because the oxygen attacks the metal, produce the powder over the metal. That powder, the oxide of that metal, is a perfect isolator. With those powders, you fabricate ceramics. Ceramics in different ways. Ceramic like this, with the oxide of copper, with the oxide of iron, with the oxide of aluminum. A lot of oxides are used to fabricate ceramics. And the ceramics are perfect isolated. It's incredible, no? The metal by itself, perfect conductor. But when the metal is attacked for the oxygen, produce the ceramics, the powder. That powder in different colors depending of the metal. Yes, for example, copper produce 3 different type of oxides in 3 different colors. You see the colors. This is a ferrous oxide, a ferric oxide. Yeah, depending of with how many electrons work the iron in the last orbit. When the iron is combined with the oxygen, produce ferrous oxide or ferric oxide. Yeah, remember that the iron work with 1 or 3 electrons in the last orbit. Okay, but we are going to study later that situation. This is the situation with the oxide, when the oxygen attack the metal. Okay, suppose that we have oxygen and we have iron. And what is the formula for the oxide of iron? The oxide of iron is... what is the meaning of that? Is that you need 2 atoms of iron per 3 atoms of oxygen to create that molecule. The molecule of oxide of iron. That molecule is stable. Yeah, but it's a lot of combination, no? It's 2 irons per 3 oxygens. Yeah. Let me check what happened in this particular. How is that formula? I have 3 oxygens. I have 3 oxygens, and I have 2 irons. And the iron have 3 electrons in the last orbit. The iron have 3 electrons in the last orbit. And let me check the oxygens. The oxygen have 6, no? The oxygen have 6 oxygens in the last orbit. 6 oxygens in the last orbit. And each iron, each oxygen need 2 additional to be stable. What element have more energy in that combination? Oxygen, because oxygen is located in that corner, and iron is located here, less electronegativity. Oh, the element with more electronegativity, with more energy, absorb the electrons. In that case, this one and this one migrate over there, and this one migrate here, this one migrate here, and this over there. That's perfect. And now the molecule is stable, and this is the molecule of oxygen. Nice, no? This is the procedure to create those molecules. This is the molecule of oxygen. But it's complicated, no? because the oxygen needed wait until other 3 oxygen be clear. Hey, my friend, come on, I have a party with other 3 irons. Can you call other guy? It's complicated. Let me check what happened if the oxygen found a zinc on the environment. What happened if the oxygen find a piece of zinc on the environment? This is the situation. This is the zinc, and this is the oxygen. The oxygen with the 6 electrons in the last orbit, and the zinc with 2 electrons in the last orbit. Once again, what element have more energy? Oxygen is located in that corner, and zinc less energy. Okay, in that case, the zinc release the electrons. The zinc release the electrons over there, and the oxygen complete A, and the zinc 0, and the molecule is this. That molecule is too simple. In other words, for the oxygen, it's better when the oxygen find a piece of zinc because attack directly. The oxygen don't need call other 3 guys and other, no, it's not complicated. It's simple, attack the oxygen. Yes, my friends, for that reason, you can put a piece of zinc over the copper or over the iron, over the aluminum, and the oxygen attack the zinc and not attack the aluminum. Because for the oxygen is simple. Can I protect the metals in my boat with other metal different like zinc? For example, what happened with the metals located here, zinc, cadmium, and mercury? All of those, they work with 2 electrons in the last orbit. They have a similar function like the zinc. Yes, but there are a couple of inconveniences with each of those metals. With cadmium, one inconvenience is poison, and other one is too expensive. It's used in high quality batteries. We are going to talk later about that. The cadmium batteries. Yeah, it's too expensive. Zinc is cheap. You found that a lot of zinc in the environment is not expensive. What about mercury? Mercury in natural state is liquid and also is poison. What about the elements in the group number 2? Beryllium, magnesium, calcium, strontium, barium, radium. Those metals can be used to protect other metals. They have 2 electrons in the last orbit. But those metals are alkali metals. And those metals react with water. The only one that not react is magnesium. Yes, magnesium is commonly used like a sacrificial anode to protect other metals. Magnesium is commonly used in fresh water. In boats used in fresh water, the sacrificial anodes are in magnesium. In salt water is commonly used zinc. Later we are going to study about that. Yes, both of them, magnesium and zinc, can be used like sacrificial anodes. Remember, when you have a molecule, for example, the aluminum oxide, the element with more energy, the oxygen, absorb electrons, this is the cathode. And the element with less energy release the electrons, this is the anode. In your battery, you have 2 terminals. One terminal release electrons, and other terminal absorb electrons. At the end of the day, the negative terminal, the negative pose in your battery is full of electrons, is full negative. This is the cathode. And the positive terminal release a lot of electrons during the day. This is the anode. For that reason, 2 years later, the positive terminal in your battery is eroded. Because this is the sacrificial anode, release electrons. We are going to talk later about that. Okay, this is the situation with zinc. There are other elements in the periodic table, magic elements. Let me talk a little about iron. Iron is a magic element. Iron have a lot of good properties and only one inconvenience. One of the most important property of iron is iron have magnetic properties. It's the only one with magnetic properties. It's the only one in the periodic table with magnetic properties. Because the magnetic properties is that we have electricity and we have millions of electronic devices in our hands because the iron. The life of the people changed because the iron. And additionally, iron is the strong element. Look at the properties of iron. It's strong, it's cheap, it's the cheapest, and the tensile strength is the maximum in comparison with the other ones, and is the most abundant metal on the earth. And the cost is the cheapest in comparison with the other ones. That's wonderful. This is iron. Don't forget, iron is magic. Other good property of iron is iron have good memory. You have a piece of iron, you can bend the iron and the iron return to the original position. What is the meaning of that? The elastic area in the curve of the formation of the iron is a big area. We are going to talk later about that. Yes, iron have good memory. It's strong, it's cheap, it's magnetic. The only inconvenience with iron is highly corrosive. It's the highest corrosive metal on the periodic table. That's the only inconvenience. It's propense to corrosion. The oxygen attack a lot the iron. Yeah? The only way to protect the iron is with pieces of zinc. Yes, because the zinc, the oxygen prefer the zinc because it's simple, one to one. Alright, my friend, this is iron. There are other important properties about iron, but the most important is the magnetic property. But let me explain something about the alloys that we are going to study later in this chapter. The alloys are divided, we are going to study, in a ferrous alloy and non-ferrous alloys. The ferrous alloys are based on iron, and the non-ferrous alloys are based in other metals different than iron. The alloys of irons are a million of alloys, steel, stainless steel, but the most famous is stainless steel. You remember how can you identify if a bolt is a good stainless steel or not? You remember that micro video? Yes, it's with a magnet. Yes, if the magnet not attract that bolt, it's because this is a good stainless steel. This is a marine grade stainless steel. And the element in the alloy, because this is iron. That alloy, stainless steel, is iron with carbon and other important ingredient, chromium. Chromium. The chromium inhibit the magnetic properties of the iron. If the amount of chromium is in between 12% and 16%, the magnetic properties of the iron disappear because the presence of chromium. For that reason, in other coming classes, diesel and gasoline, we are going to take a sample of the motor oil in your engine, and we are going to take the sample to the laboratory, and we are going to analyze the report of the oil sample. Yeah, you can buy that poster in my web page. You can analyze the report. The only element internally in the engine, stainless steel, are the piston rings. If we found that a lot of chromium in the oil sample, it's because the piston rings are broken or are gone. In that case, we have low compression and we have blue smoke. Yes, easy. I check the report, high level of chromium, low compression. Oh no, check the compression. Oh yeah, it's too low. Yeah, the report, that report. Chromium. That's chromium. Magic. Yeah? Alright, this is chromium, other important element that we are going to analyze. Chromium inhibit the magnetic properties of the iron and also the corrosive properties. The stainless steel is practically zero corrosive. It's corrosive, but it's practically not corrosive because the amount of chromium. Incredible. This is in ferrous alloys. In non-ferrous alloys, alloys of copper, alloys of aluminum, alloys of magnesium, non-ferrous alloys, the non-ferrous metals are corrosive. Less than iron, but they are corrosive. The only metal in a non-ferrous alloy that inhibit the corrosive properties is nickel. According with the amount of nickel in the non-ferrous alloy, the alloy could be non-corrosive. Yes, we are going to study a lot of non-ferrous alloys. And we are going to study which alloy is marine grade, which alloy is authorized in marine environments, which alloys are not, like brass. Brass is not allowed. We are going to study later why. It's basically because the amount of zinc. Okay, but nickel in the non-ferrous alloy inhibit the corrosive properties. And chromium in the ferrous alloy inhibit the corrosive properties and the magnetic properties. Important, very important nickel, very important. And we study carbon, silica, and germanium. They are semiconductor materials. And what other important metal we are going to study? We are going to study the aluminum in details, because aluminum is one of the most important metals used in the fabrication of boats. A lot of brackets, towers are fabricated in aluminum, and hulls in aluminum. This is important. Copper is important. We are going to fabricate a lot of heat exchangers in copper. We have a famous copper alloy. Is the copper nickel alloy, the 90-10 alloy. 90% of copper, 10% of nickel. That alloy is zero corrosive. Wonderful alloy. With that alloy, we fabricate heat exchangers in contact with the salt water. Yeah, that alloy is expensive alloy. It's perfect for marine environments. Okay, this is with nickel. This is with cadmium. And yes, we are going to study later other metals like magnesium. In the class of diesel and gasoline, we are going to analyze the oil samples, and we are going to study other additional metals. But with this information, we are ready to start the next chapter about the division of the materials. In the next chapter, we are going to study organic materials, inorganic materials, ferrous alloys, and non-ferrous alloys.